In conventional photopolymer 3D printing technology, after exposure and curing of each layer, it is necessary to overcome the sticking of the product. Move it to ensure the inflow of the photopolymer and repeat the cycle. Often, in this process, the exposure is not carried out, so the printing lasts a long time. To solve this problem, it is necessary that the photopolymer in the boundary layer remains liquid even during exposure and without the use of inhibitors. In order to make 3D printing of photopolymers continuous, fast, and versatile, we invented CPWC technology by means of microfocusing elements. The energy of actinic radiation is distributed in the boundary layer so that most of the photopolymer is not exposed and it remains liquid. The polymerization surface then acquires a microscopic relief. The contact area of the product with the optical interface is reduced by 150 times, as much as the force necessary to overcome sticking, and the photopolymer flows freely in the dark area of the boundary layer right at the time of exposure. The size of the microscopic relief is only 10 to 30 micrometers and does not affect the properties of the product. We have developed and manufactured and tested 3D printers that implement the invented and patented CPWC, continuous production with wavefront converting technology. In this video, you see the process of continuous printing of the product by our technology at a speed of 10 millimeters per minute or 600 millimeters per hour along the axis of construction. Now we can use the most diverse photopolymers for high-speed continuous 3D printing, regardless of the type of polymerization. The creation of CPWC technology is a significant step in the development of the additive industry. Currently, we are creating a fully functional prototype of an
based here in East London. ScanLab projects provide 3D laser scanning services for a number of different clients worldwide, and that effectively means that we'll go out with a laser scanner and capture reality, whether they'll be on the scale of a building, a valley, or part of a large sculpture. One of the machines that we use to capture reality is the terrestrial laser scanner. It has an infrared laser on board and a series of mirrors. What happens is the signal is generated in this side of the scanner, is bounced off the mirror and then out to the world. Its return signal as it comes away from that surface is measured, and that's how it senses the world. And the amazing thing about that is that it's doing those measurements about 1 million times per second. So the model it's able to produce, the point cloud, which we call it, is incredibly dense. One of the recent projects we've had was with the Science Museum, who closed a gallery to make way for a new one, and part of our involvement was to make a record of that, not only as a kind of archive, but also a way of keeping the gallery open digitally for all kind of people across the web. The point cloud is a new way for us to look at the world. It is effectively just lists of numbers. That's a really kind of interesting medium, and much like photography of the kind of 1800s, the kind of the wet plate traditional photography, it's very much in its infancy. And there's a certain kind of aesthetic that the point cloud gives, which is very elusive, very alluring to us, and we're really interested in exploring that as a creative output for some of our work as well. We did recently an exhibition with Brigitte Staputis, who's the head of couture at Vivienne Westwood. And we organised a day to do a photo shoot, but used the laser scanner to shoot the models and the dresses instead of a traditional camera. So we had an amazing time working out poses and how the scanner looked at not only just the models, but the architecture, the volume and environment within which the models were placed. This information really we can view through our computer, but that's not the only way to experience our information. One of the other ways, and quite excitingly, is the Oculus Rift, which will be allowing us to kind of walk around that environment, kind of almost immersing ourselves. I imagine our city of the future would be in two ways, both the virtual and the real, and that the lines between those will become increasingly blurred.